and welcome to episode 357 of The Joy of Coding. My name is Mike Conley. It's so good to have you here. Going to be live hacking on some Firefox stuff today. Going to continue digging into some work that we started a couple weeks ago on making further improvements to the Windows jump list stuff that we worked on for most of 2023, and we're doing more refinements. Let's start by sharing my screen and getting a shot of what's going on today, getting a real good breakdown of what we're hoping to do. Well, guess what, gang? No plan survives breakfast. It's February 28th, 2024, episode 357. I say this every time. Yeah, no plan survives breakfast. I think I know what I'm going to do. I think I know what we're going to cover, but yeah, well, it might not happen. We might go sideways, might get stuck. We might find out that I can't connect to my VM or something, and we'll just work through it. You know, that's what we're capturing here, is you're going to watch me working like I would normally be working. I'll just try and think out loud while I'm doing it. And sometimes plans don't go as you'd think. That's the first thing. The second thing is that the agenda that we're looking at is something you have access to. So if you're watching this on Air Mozilla, over in the details section over there, you should find a link to this agenda. For diode.zone or YouTube, it'll be down in the video description, and in Twitch, it's down in the channel details. And as I update it and like add stuff, this little spinny thing will spin, and if you reload the agenda, it should be up to date. Let's actually double check that. Let me look at the agenda. Oh, guess what? It's not working. Hold on a second. Let me just go ahead and make sure that that's getting synced. One sec. There it is. Just took another little kick there. Just had to kick it a little bit. All right, so what are we working on today? Well, first of all, is my mic too hot? I realize I'm redlining. I'm going to turn down the gain just a little bit. Is this better? Is this better? I'm no longer here. I'm trying not to redline. So now I'm nice in the yellow. I'm in the yellow zone. Let me know if that's better or worse. Okay, so what I was hoping to do today was to continue with last week's work. We were starting to get the Favicon stuff that's built into the jump list system. We were working on getting the sort of the Favicon fetching part to work properly and to not do main thread IO. The actual fetching of the favicons does occur off of the main thread and writing the favicons to disk, but checking whether or not the favicons are present happens on the main thread. And so the next step is to really just get the whole thing off of the main thread. And that's what we were working on last week and the week before that. I did want to give a quick update on the jump list stuff. I've heard from QA today that they've been testing the new off-main thread Windows jump list on Firefox Beta 124, and so far have not found any major issues. So we are on track, presuming they continue to test it and happen to miss the first part, but sounds okay. Okay, good. I'm glad that the microphone is working. If all goes well, if QA doesn't find any major issues and we don't see any like stability issues suddenly arise, then the new off-main thread jump list will go out in 124, and users may not notice, like the behavior of the jump list should be the same, but but it should ultimately be more responsive because it's no longer blocked on main thread IO, which is good. The whole browser becomes more responsive. So I can get rid of this line now. I actually need to sort of come up to speed. I didn't really do any prep before this episode, so I forget where we got to last week. And so what I am actually going to do is let's take a look at what we did last week, recordings, and see where we left off with episode 356. So I'm just going to fast forward right to the end. This is a sort of a meta Joy of Coding episode. So where did I get to? That's the last. I want to get right to the very end here, where I flip back to
have it pass the path.
I don't know if
it
you
just
can
be
hear
ignored by the old version, the old consumer of this stuff. So the runnable, the decoding, the downloading of the favicon and the encoding of it, that's fine. It's the writing where eventually the runnable is run.
Ah, this part, yes, the runnable.
Are we able to pass more information like the path here? That's something to think about next week. Hey!
So now it's next week. So we were talking about What were we talking about passing to the runnable? Let me back that up a little bit.
The old consumer of this stuff. And it just be ignored. And somehow, Favicon cache is available. These runnables, I'd love it if I could somehow have it pass the path and it just be ignored. Have it pass the path. These runnables, I'd love.
Hang on. What are we talking about?
This is awkward. This is awkward. We might end up having to rewrite humongous chunks of some of this. Our callback.
Because there's a callback.
Once our callback is fired, but we have to get the path out somehow. Oh, this is once our callback.
Right. So our callback. Yes, now I remember. Okay, so we're caught up to date. Let's go back to let's go to my Windows machine. I haven't touched the editor since last week, so we're in the same spot, more or less. But the problem that we're trying to solve, Favicon, cache, get, or cache, was it? Cache, obtain cached icon file async, this one. So we're trying to have a thing that returns a promise, and that promise is supposed to resolve with the path of the file that either exists already on disk or gets downloaded and then cached to disk, and then we need to get that file path out. And the way that a lot of the helpers that the old mechanism uses, the way those work is you kick off this runnable, but the runnable, whenever it completes, like where's the part where there's a callback? Where's a good example of this? Obtain cached icon file. Here, yeah, you can get a runnable to run after this job has occurred, but you don't really get a result from it. But I wonder if there's a pattern that we can. I wonder if there's a pattern that we can use. Here's what I know. NSI runnable. That's the interface for a runnable, a thing that is like a task that will be dispatched to some event queue somewhere and eventually be consumed and run. You can think of them as a task. There is a run method. That run method doesn't take any arguments. But what we can do is because we know who we can have control over the class itself, like the runnable class in this case, or do we? Do we have control over this? Obtain cached icon file. Who passes us? Who calls us? Obtain cached icon file. So this one doesn't use the runnable. That's helpful. Legacy one also doesn't use the runnable. And data object does use the runnable. And what it is it creates a runnable function. So really what we should do is get this to use our new mechanism, our new promise mechanism, rather like trying to get the, oh geez. So we create a new runnable function. So it's just this like little lambda, and it's just a function. It takes a single thing into scope, which is E. E is some kind of event, and we see if after we get the favicon, we might either send a signal or send some kind of message. I see. Let me think here. Because what I was originally thinking is if the runnable, if we can control the class, then we can have the runnable set a member after the path is obtained on itself. And then within the runnable function, you can then access that member. But I think what we might be doing accidentally is trying to shoehorn. We might be doing more work than we need to. Like if we can convert this to use our new promisey system, then we don't even need to do the callback thing anymore. And we can rewrite all of the callback stuff. Let's see what this does real quick. Get file content internet shortcut. Create the special format for an internet shortcut and build up the data structures that the shell is expecting. This is like a Windows specific thing. So given some, I presume we're implementing some function. I don't know, like we're returning an H result NS data obj. So, you know, this is very Windowsy. This is very Win32. These are Windows structures. I can tell that. But we're doing some XPCOM. We get the URI for extract shortcut URL from what? We are an NS data obj. That's what's going on. We are implementing something for NS data obj. So we are a data obj, and we read out the URL. Presumably it's encoded in some like Windows specific format. We extract it. We construct an NSI URI from it. We get the ASCII spec. Then we see whether or not it's true that we're supposed to be doing this. K shell icon pref shortcut favicons. What is the default value of this pref? It's true. Okay. So if it's not true, then we skip all of what we're about to do. We instead do, we construct a shortcut string, format string, and we insert some stuff into it, presumably. And, you know, the Windows is happy with this sort of shortcut file. So that's what we're doing, is we're constructing some kind of shortcut file. Now, if we do want to embed the favicon, then what we do is we create some structures, we request the favicon, and if and when we get it, then if E is waiting an auto set event, then we signal it, we unblock it. If it's not waiting, we could not wait until the favicon was available. We have to refresh to reflect the favicon. So you say, okay, well, send Windows a message. Hey, I guess we updated the favicons, yo. Meanwhile, while that's happening, we get the output icon path for the ICO file. So this may or may not have anything in it yet. And then we write that, okay, I see. And then we write that into here. And tell me more about this auto set event. E. Auto set event implementation. It's like some kind of signal. It's like it's not a mutex. It's like a monitor of some kind. I think. With an auto close event, wrap not null event auto close event, and that is a wait for single object event. That I think is we are polling an event queue. I think that's not what it means. Checks the current state until the specified object is in the signaled state. So we're not polling an event queue. We're waiting for us to enter a particular state. And then the second argument is the timeout interval. It must have the synchronized access. We're waiting for access to a thing. We're waiting for access to some object that has there's like a mutexy thing going on, and then this is a timeout. And so if we are, oh man, we cannot wait until the favicon is available. We have to refresh to reflect the favicon. Okay. I think what we want to do then is to have this use the async mechanism and then use then here to do this stuff. Now, the output icon path part, what does this do again? Obtains the icon path of favicon. If successful, we generate the name, sure. So it doesn't check to see whether or not there's actually anything there. It's just, given this URI, this is where we would put the icon file. And that's important because we haven't necessarily populated it yet. That should still work. We don't want to block doing that. So we want to just do this exact same thing, but inside the then. And we don't even need, in this particular case, we will not need the path. Actually, come to think of it, now that I think about it, we don't need to resolve with the path because it's deterministic. It's deterministic because we know the URI, we know what the path will be. So we actually don't need to have our promise here, the obtain cached icon file async promise. We don't need the callback to resolve at all with the path. We already know what the path will be. File. So instead, if it exists, we resolve. If it doesn't exist, we're going to queue up retrieving it, and then our callback will be called. And then what do we do? Runnable, cache, favicon URI, async. We do this stuff, we get the callback. I know this is all very familiar. Async favicon data ready. On favicon data not available. We'll go and get it. On complete, if there's no data, then we don't do a thing. We do on favicon not available. Then it looks like we'll fall back. We'll fall back to some other favicon and write that in instead. Otherwise, we'll do all this work. And then code and write icon mrunnable. Yeah, when is the mrunnable run in the failure case? Mrunnable. I don't know if we'd ever actually run it in that case. That might be return channel async open listener. Listener is a new downloader, and we have a download observer, which is this thing, my download observer. New my download observer. What? Okay, on download complete. Seriously, is that what is this? My download observer? Well, what do you know? Why is that? That's kind of bizarre. Download observer. On download complete, doesn't do much with it. Okay, don't need to worry about that. We just need, I guess, to satisfy the interface. We get a listener out. And then we async open, get the file. I actually don't know if we end up async encode and write, and then we pass the runnable over here. And then the runnable over here will call the runnable only on success. That's really interesting. So it means that there are cases where the runnable will never have resolved. The runnable will never run. It seems like a mistake. Seems like a mistake, but something to note for later. I think what I'm coming to the realization of, though, is that we can still use this stuff and have our runnable do the work. Like, have our runnable call this stuff. The async favicon, all this business. This thing. Cache, icon file, runnable, forget. Like if we call this from within here, if the favicon doesn't exist, and then have it resolve once our runnable, like have our the runnable that we pass it resolve the promise using the calculated icon path that we know of. Because we already know what it would have been. Check if exists func. Okay. Well, where were we? We were dealing with this. We had gotten to the point where this is a familiar problem. It's not a pointer, promise holder. Sure. And we used a unique pointer. And I presume we're still in the state where this will not build. Basically, you just heard me think out loud. For the past half an hour, you've heard me think out loud. But let me take an opportunity to write my thinking down here. Do we have an active bug? Yeah. So what I'm thinking, reconciling the runnable, the NSI runnable passed to, what is it called? Obtain and cache or something. A cache icon file from Favicon URI async. With the promise. So the good news is that we actually can deterministically derive the saved icon file location from the MSI URI without actually having to do the download. Like, that's part of how all of this works. We know where the icon file should be if it exists, and if it's not there, we go and get it. So what we should do is resolve the promise if and when the cache icon file from Favicon URI async call runnable is fired, and have the caller of cache icon such as such resolve that promise with the path of the icon file. H1 tags are like Highlanders. There can only be one. Should there? Oh, okay. Good call. Good call. Actually, this is almost like a sub-bullet of this thing. Wait, cache icon. Yeah, okay. It's not. It's a sibling. Okay. Scooby-Doo. So I'm gonna guess that didn't build because no matching member function call to resolve if exists. Candidate function template not required because it requires 2 arguments. The path and the method name. Let's see an example of that being used out in the wild. I think I know what it is. I think it's supposed to be funk, yeah. Renegades of Funk. So what we have to do instead is dispatch... Oh, this is annoying. We're going to dispatch a runnable to run on the main thread to call... I think we have to do that. To call... cache icon file from Favicon URI async. So we're going to pass the promise holder back to the main thread. Okay. First of all, does that compile? If it exists, then do this. Then else. I guess if we ever reach here, we don't need to else. We know if we're here, then either the icon file didn't exist or it was expired, in which case we need to do the thing. So we're going to dispatch a runnable to the main thread that will request the favicon call. This is so circuitous. I will call such and such to request the favicon. Is there a better way? Favicon URI async. Is there a better way? calls this thing? Maybe all of this like marshalling back and forth between, yeah, it's only those two places. That's really clumsy. Like we send a message to the background thread to check for the presence on the disk and the expiry and stuff. And if we need to re-request the favicon, we send a runnable back to the main thread. And its job is to then queue up a runnable on a different, the IO thread to, yeah, that all sounds wrong. That all sounds wrong. Is there a way we could put that initial logic of async callback, get favicon data for page callback? For example, could we have this it's the same problem. It's the same problem. And the favicon service, like, even if we had this do the work off of the main thread, you'd have to come back in order to invoke the favicon service. Oh, it's a pain. How is it done for Mac and Linux? I don't know. I don't know. This is very Windows specific. Good question. Widget. Let's look at Linux GTK. Is there some kind of favicon thing in here? Widget, GTK, and it's favicon service. Favicons. I'm gonna guess we don't do anything for GTK. It doesn't look like we do. And then for Mac OS, we may actually, I don't actually know. I wonder if we delegate it to the operating system because they have support for it. Or we pass the icon data. I mean, in this particular case, like jump lists are very Windows specific. There's not really a great analog for what we're trying to do here, at least as far as I can tell, for Mac OS and Linux. Like Linux has some kind of similar menu. I think there's a file that one writes to. It's like a .desktop file that describes the contents. Whoop. Describes the contents of the menu, or maybe like actions here, yeah. But I don't think that there's an equivalent where we'll like list recent sites or something. I think this is very Windows specific. Yeah. Okay. So we might be stuck with our sort of clumsy architecture where we do the check off the main thread, check fails, queue up work on the main thread that kicks off work off of the main thread. Are we sure it's not a better way of doing that? Given the I don't want to rewrite everything. Get favicon data for page. What does that do? If the page icon is not available, try to return the root domain icon data when it's known. Okay, so this may do like network requests. It'll do its best. And what we're really talking about is like an on-disk cache in front of this stuff. And we don't want it to be checked on the main thread. So this is awkward, but that's what we're going to do. You know, my reviewers might have better ideas. So let's look at dispatching to the main thread. Get main thread serial event target sounds right. New runnable function. On helper. Obtain cached icon file async. I don't know what I'll call this. Disk check. Disk cache check. And this runnable function is icon retrieval. Favicon service retrieval. And then we're going to move the promise holder over here. The actual icon file. I guess, yeah, we can move that too. We don't need the timeout. Let's move this in here, see what happens. Does that build? Okay, doesn't like it because construct using standard move. That's what I'm doing. No capture default specified. Did I miss something in my Lambda? Standard, move, promise holder. Looks right. What did I miss? Variable promise holder cannot be implicitly captured. It was declared here in this lambda expression. Capture by capture promise holder by reference. So it's suggesting that I put an ampersand here. Oh, it's also, there's an error on line 118. It's not liking some of my parens. Did I screw up my parens? Here, that's right. This is wrong. What did I miss? What did I miss? Parentheses there. Close bracket here. What did I miss? What did I miss? That's that. Ah. That one. Maybe that's enough to make it happy. I got a feeling no, though. Oh, that's handy. It was saying, hey, to match this parentheses. I didn't notice that before. That's handy, knowing how you want me to balance. Okay, so it's like, hey, you can't do that. Call it a deleted constructor. Unique pointer has been explicitly marked deleted here. Construct using standard move. I'm trying to. Variable promise holder economic. Make unique. Unique pointer. That's unique pointer. Can be assigned directly to unique pointer. What does it say about? Nothing about threads. Smart pointer that wholly owns a resource. Ownership may be transferred out of unique pointer through explicit action, but otherwise the resource is destroyed when the unique pointer is destroyed. It's impossible to copy a unique pointer. Copying an auto pointer obviously can't copy ownership. So what happens if you try to copy one? Ownership is transferred. Unique pointer solves this problem by being movable rather than copyable. You pass move, and in doing so you indicate you're moving ownership out of you. Yeah, out of one scope and into another. So we moved. Standard auto pointer proceeds like this. You create a thing, deletes the int. No problem. Unique pointer owns that int. G2 leaks its int. Still requires deletion. No, freed. Okay. Wow, this is pretty complicated. Remove is derived. Specialized for array types, that doesn't matter. This transfers unique pointer sole ownership of the data to the fresh unique pointer created in the calling function that will then solely own that data. Anything in here about runnables? I mean, I'm trying to move it, gang. Is it the fact that it's called? Like, what's the problem here? I moved it here. I presume if I don't move it, then this is going to compile. Constructor. Pointer promise holder. Let's look for more cases of using unique pointers, passing them between threads. Standard move, make unique, promise holder, or any, or this in particular, make unique promise holder. That's what I want. Let's see if there are any examples that we can look at. So there are a few. And what happens is that gets moved into one lambda, and then it's done. Here, moved into one lambda, and then it's done. Here, moved into this lambda, done. Oh, no, and then move, standard move holder into get GMP content parent. So this one moved it again. So what's wrong with mine? How come you don't want me, man? What if I rename it? Is there confusion there? I don't know why there would be. So it's making a suggestion. It's like, hey, you know, have you considered putting, have you considered doing this? Which is just doing this. Promise holder. That's its suggestion. It feels weird to not move it. I feel like I think it likes it. All right, well, to do. How come I can't standard move promise holder here? Is this safe? All right, great. So now I'm on the main thread again. And what I want to do is call that function and we're going to pass in all this stuff. Turns out then I'm going to need the URI. I am going to need the ICO file. I am going to need the IO thread. I will need to construct a runnable. A URL shortcut. Oh, yeah, whether or not. So this, use shortcut cache dir. And everything else is out here. Okay, this is pretty sloppy, but here goes. We're gonna pass all that stuff along. Let's pass along. ICO page URI equals standard move a favicon page URI, and then IO thread equals standard move IO thread. I don't think it's gonna like this. And then the use shortcut cache dir. I think it's just a primitive that we can just send over. We don't use any of those things except here, where we basically pass them back. Page URI equals standard move page URI. IO thread equals standard move IO thread. And then what was the last one? Use shortcut cache dir. And then we will plug these things in instead. Page URI, ICO file, IO thread, use shortcut cache dir, and now let's not pass in a runnable for now and just see if this compiles. I'll be fairly surprised if this compiles. Some great Winamp chat going on in the chat. People are thinking Sublime. This Sublime icon kind of looks like the Winamp icon. It's pretty cool. Too few arguments. Can I pass null? I think I can pass null. I mean, see what that's all about. Okay, binding reference, ref pointer, value of type, const ref pointer drops the const qualifier. Just gonna make a guess. I'm gonna make a guess. Can I do this? I'm really just kind of hacking, slashing, and guessing. I am way outside my comfort zone. I would love something where it's what we're dealing with is this bizarre intersection of C++ and JavaScript, XPCOM promises, Moz promises, and multi-threading. Use of undeclared identifier. I've never heard of IO thread before. So let's AIO thread. AIO thread. I got so many bad feelings about this. Hi, Mike. There's a question. Eric03 writes, hi, Mike. I'm an intern onboarding at Mozilla in 2 months. Hey, congratulations, Eric. I chose to use the MacBook Pro, but I was told it would have trouble running a Windows environment. How do you run a Windows on your MacBook? Technically, I'm not running this on my MacBook. I am signed in using something called Microsoft Remote Desktop. I'm using the RDP protocol to remote into my Windows desktop. There's a tower sitting under my desk. See, still having a problem there. So that's not to say that you can't virtualize Windows on your MacBook, but you might have some performance issues. What I would recommend, if you can, you've got two choices, and it depends on what team you're interning with. Will kind of inform your choices. If you're just going to be like doing artifact builds and testing, you can probably get away with using VMware Fusion on your MacBook Pro. Like the M1, M2 chip they're fairly powerful, and booting up a Windows VM fairly powerful. Like, I think you'd get away with that. I think it would work. If you're doing full builds, it might be more cumbersome. It might take a while, for example, at the very least, to do full builds in a Windows VM inside of your MacBook Pro, even though it's an M1 or an M2 chip. The alternative is to, if you've already chosen the MacBook Pro laptop, I don't know if you're going to be going into any of the offices, but you can get a temporary Windows loaner. You just get a secondary machine, ask for a Windows loaner laptop. Those are fairly easy to come by. There's usually, a locker somewhere with reference laptops that you could snag. So hopefully that answers your question. All right, so this is not helpful. Passing threads this way, it's not working. Binding reference of type ref point, value of type const ref pointer drops const qualifier. So I noticed this happening with elsewhere, where like you know what it might be? Is this silly? A const reference to the thread? And then passing the thread itself. Because I think the lambdas, I'm on the desktop integrations team and my manager is really pushing me to use Windows. Yeah, I don't know if you're going to be in the Toronto office, because I know that's where some of the desktop integrations people are. If so, I'm looking forward to meeting you in person. You can ask for a Windows loaner to go alongside your main MacBook Pro developer machine. For example, I can't believe that's linking. It worked. It worked, gang. This is just means it's building though. It might absolutely explode, but here we go. So what we need to do instead of passing null pointer, is we need to pass some kind of runnable, and the runnable that I want to pass is like this. Let's look at the one call that we do with this thing from, not cache, not this one, but the consumer of this. Whoops. The consumer, which is over here. So obtain cached icon file. The caller of this, we had one over here, and it uses a runnable function. This is what we want to do. So another runnable, gang. We're throwing in another runnable. This is such a mess. Okay, runnable function. It's a chain of fools. And this is Favicon helper. Obtain Favicon file async, favicon retrieved. It'd be great if we could reformat this. Do we have some helpful reformatting? No? Fine. I'll do this like this. This is quite poor. Runnable function like that. And then we're gonna do this, and this, and this. And we're not gonna do that. And what did I forget? What am I missing, parentheses wise? Got that. Need that. There it is. Okay. So now what I need to do is I just need the promise holder now. So I'm going to move the promise holder Now this is still on the same thread. So I should probably ensure that. Assert. Do we have some asserts? Moz assert is main thread. Yeah, here we go. So moz assert is main thread. And we're gonna moz assert over here that we're on the main thread. We're gonna assert over here that we're not on the main thread. And then promise holder resolve if exists. Oh, we actually do want the icon path. So we're gonna move ico file equals standard move ico file. This is so dumb. NS result. Put this up here. We're gonna promise holder reject if exists. If NS failed RV, promise holder reject if exists. We're going to reject with our error code. Else, promise holder resolve if exists. ICO file path, func. Does it build? Reject is misspelled? Oh, I think I fixed it. Yeah, I fixed it. You're good. Thank you for the highlight. Wow, what a mess. It's a bit Rube Goldberg. What are you gonna do? You kind of need the parent, the main thread to do a bunch of this marshalling. The call comes in, you send off some work to the IO thread, you come back with the result, and based on that result, actually, what happens if we only will resolve in the event that we successfully got a thing. I kind of wonder if we can save some repetition by moving this out. Yeah. File path, RV, iCode file. Okay, at any rate, it built. So now I'm very curious to know what happens when we call obtain cached icon file async. Now, did I expose this somehow via who? Jump Builder uses it in obtain and cache favicon. And I think what I want to do is SI jump list builder, obtain and cache favicon. We're going to have this promise obtain and cache favicon async in NSI URI favicon URL. And so then we'll go over to jump list builder dot cpp obtain and cache favicon, and we'll do the async one here. make sure that that builds. And then oh, there needs to be like an implied right. Jump list builder.idl. Because we're returning a promise, there is an implicit JS context. We have a JS context, so I'm actually gonna kill this build. We're gonna do it again, and that means we actually have to. Oh, I'm gonna kill the build again because we have to change our function signature. Jump list builder. .cpp. I think those two come at the end. Yeah, JS context, CX, and then the promise come at the end. Obtain and cache favicon. Come on. There we go. So that, I think, should build. Gonna need to format the heck out of this. We're going to want to do a lot of the same stuff we've been doing up here where we assert some things and create a DOM promise holder. So it's fairly happy with what's going on. That's good. DOM promise holder, and then we're gonna call obtain cached icon file async. We're gonna pass those arguments, and where's our then? We gotta do the then. File async. Then this is how we do that. Say then. And then this is the resolution. And this is the rejection. Rejected. Okay. So let's format this in a better way. Promise with undefined. Not exactly. We don't want to promise with undefined. We're actually going to be getting back a string. And then this is the rejection. This is correct where we will and then close the then. Done. And then that I need to change the structure of this. Instead of a Boolean coming back, we're going to be getting a string. The string is winutils, an NS string. Okay. Jump list builder. NS string. A ICO file path. I'm just going to promise with undefined. Okay, build it. Man, my brain is melting. This is wheels within wheels, everybody. I'm definitely going to be relying on... it doesn't know what I mean. Icon file path. Favicon URI. Oh yeah, the signature is different. What's it supposed to be? winutils.h. It's supposed to be the Favicon URI, the thread, and the cache dir. Favicon URI, the thread, and then the cache dir. And in this case, it's going to be like icon Favicon helper cache dir jump list cache dir. Mozilla widget Favicon helper jump list cache dir. Right? Is that what it is? Jump list cache dir. Yeah, icon cache. Oh, I'm missing one. Icon cache dir. All right. Build that. Now, what you think about that? Gonna have to stop soon. I have a long meeting after this stream, and I need to rest up and get my head kind of straight before that. I can't believe this is building. That's crazy. All right. Let's go one further. Maybe resolve with the string. How do we do that? Maybe resolve, and then can we pass in the string, the NS string? Maybe resolve a ICO file path. Too good to be true? Let's find out. Build again. Let's just do build binaries. Go, 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 go. It's linking. What are you linking about? Has anyone ever seen that that commercial? There's a TV commercial from a long time ago. I don't remember what it was for. I think it was for like Rosetta Stone or whatever that like language tool. A German like Coast Guard is like a radio operator is working. He's all alone. He's by the radio, just German Coast Guard monitoring the radio. Suddenly, this British transmission comes in from I guess a ship from Britain, and it's going like, "Hello, is anyone out there? SOS! We are sinking! We are sinking!" And the German Coast Guard officer, who I guess for him, I mean, most people I know in Germany speak English quite beautifully. Like they're basically fluent and their pronunciation's incredible. But this fellow, I guess he's rather new at English, and he's hearing this transmission. We are sinking. We are sinking. And he goes, "This is German Coast Guard. What are you sinking about?" And I thought that was quite funny. At the time, anyways, I thought it was quite funny. Maybe now I also think it's quite funny. Okay. What are you thinking about? This is a debug build, so this is going to be kind of slow. We're going to launch this puppy. do... What are we gonna do? I would like to get access to the jump list builder. There used to be builder. Whoops. There's jump lists, so I'm gonna get access to the. We used to do this all the time. Win taskbar jump list. Okay. Open up the console. That's going to take a second. Ooh, come on. Come on now. Debug build taking forever. Open the console. Maybe we should leave it on a cliffhanger. Oh, here we go. This is going to be painful, but here we go. Let win taskbar jump list equal Chrome utils import ES module resource modules Windows jump lists.sys.mjs. Is that what it is? Jumps lists. Resource modules Windows jump lists. Yeah, that looks right. Let's see what happens. Do I get access to it? Yeah, win taskbar jump list. Here's the thing. Let's get access to the builder. There's our builder. Obtain. Prototype builder. So there's like a builder, and then within that is a builder, right? Builder. Is that correct? Yeah. Obtain and cache favicon async. Okay. Now it's going to expect a URI, so I'm going to construct one. Let's do one that's already... Oh, wow. Like, for some reason, none of those have been retrieved. So let's do one for my personal website. Let Mike URI equals services.io.new URI HTTP, what was it? https://mikeconley.ca //mikeconley.ca / Okay, got ourselves a Mike URI. And now I'll say obtain Mike. I'm going to do that, and let's await it and see what happens. Now this may crash, but let's find out. It crashed. Pretty exciting stuff. Assertion failure. No promise. All right. The assertion failure was on line 1084. Yeah, I got a feeling what happens is that, like... Wait, what? 1084. By the time we get over here... Was promised destroy, default delete. The unique pointer. The movement... I got a feeling we're doing this wrong. This moving of promises. mean, it should be straightforward to move a promise holder, right? Promise holder, promise holder, promise holder. Main thread pointer handle, but that's for a DOM promise. Now, should that be... Should we instead be using... Could we use a Moz promise there instead? Because, like, I think you can just kind of pass it anything. Why not? Because we know that that works. Okay, I'm gonna take it's 2:26. I don't think I've got time. Probably don't have time. Let's see if it'll at least compile. So we've done this before. Jump list builder. What did I do? I was like, hey, here's a promise holder. Create one of these things. We're gonna wrap our promise in it. And so I think I want to do the same thing, except it's going to be a Moz promise. Moz promise holder. So make unique favicon this thing. Main thread pointer holder promise holder. And then we're going to insert our promise in there. So we're going to say what? Ref pointer obtain cached icon file async promise equals new. Sure. Let's see what happens when I do that. And so then we get this like promise holder thing. And how do we feel about moving that around? Because I clearly do that here. I do standard moving. And maybe I can do that as well down here. Because I think I've done that before. Are you going to compile? And no matter what, if this compiles, I'm ending the or it doesn't. Either case, I'm ending the stream here, and we can keep going in next week and seeing where we're at. Doesn't work because no match constructor for initialization of Favicon. I need to construct it better. New Moz promise. Promise holder. How does it do it? When you say ensure. I said I wasn't gonna. I said I wasn't gonna do this. Ensure method name. So it's a new promise, and then you pass the method name. Okay. I said I wasn't gonna try it again, but I am. I can't resist. I cannot resist. So new favicon func. One more time. This time with feeling. And then seriously, no matter what, I'm ending the stream. In fact, I'm gonna just do a drum roll now. Let's do a drum roll. We're not even gonna check to see if it's like it'll do the right thing or if it fixes the crash. Yeah. No matching construction. No matching constructor, rather. Because it's expecting more than that. It wants a Boolean as well. No, I'm going to resist. I'm going to resist. So let's end it there. Thanks so much, everybody, for watching episode, what was it? 357 of The Joy of Coding. I hope that was interesting. Let me know what you thought. Made some forward progress with some fairly Rube Goldberg-y architecture to Marshall's stuff between the IO thread, Favicon service, and the main thread. But we got something that ultimately builds but crashed when used, trying to use a main thread pointer holder instead. Main thread pointer holder. What's it called? NS main thread pointer handle instead, because maybe that's better. Could really use some help, maybe from our media team, which definitely uses promises, Moz promises a lot. Maybe what I'll do, actually, if people don't mind, I might talk to the media team separately outside of this stream so that next week when we come back, I'll have a better sense of how to maybe do this properly. As opposed to like getting all of this stuff done and then having to burn it all down if and when they come back with like, here's what you're actually supposed to do. So if that's all right, I'll do that. And then I'll give you a full brain dump of what I learned. So to do, talk to media team about the right way of doing this. All right. I'm going to end it there. Hey, thanks so much, everybody, for watching episode 357 of The Joy of Coding. Let me know what you thought. There's a form at the end of the agenda here to rate this episode. I'm going to drop the link to rate this episode in the chat. There it is. Let me know what you think. I read everything that comes in. If you have an idea or if you have a question or something, I can try and answer it on the stream. You can just let me know using that form, and I'll do my best. Each episode gets its own unique form, so feel free to be as specific to this episode as you'd like. And that's it. Thanks again, everybody. Have yourselves a great week. I hope it's a good one. And I'll talk to you soon. Take care, everyone. Take care, everyone. Bye-bye.
The joy of coding.
See ya.